All right, good evening. This is another live training session by Unity Technologies. Scriptable objects, an introduction to these versatile data containers. Scriptable objects. I'm going to give some boilerplate first. We're going to start off with some basic information about scriptable objects, some basic information about serialization, some of the basic ways that we handle scriptable objects, and then afterwards, once we've got some of this sort of boilerplate, this PowerPoint keynote session out of the way, we'll then go in and take a look briefly at some of the examples that we have for today, and then try to answer some of your questions. So, scriptable objects. Scriptable objects don't often work on their own. To work with scriptable objects, we often need to use editor scripting. Editor scripting uses Unity's immediate mode UI, and so let's go ahead and take a look at the scripting guide. I've got PowerPoint running, which isn't very cooperative for me of putting anything in front of it. So let me see if I can actually grab anything. And oh, yes, it does. Hey, look at that. There we go. There's the Unity manual. And if we come down to the UI and we look at the bottom, the immediate mode UI down here, this will give us information about the basics of the immediate mode UI. The immediate mode UI is important because a lot of scriptable object work, and it's a little bit less so now, you'll see an attribute that we have, is also deeply rooted and deeply related to editor scripting. And all editor scripting is done in our IMGUI and our immediate mode UI. As a matter of fact, the entire Unity editor is written in IMGUI, and so when you write your own editor scripts, you're essentially rewriting the way that the editor looks, the way the editor performs for you, and you can write a whole bunch of tools. And we'll look at a little bit at the tools that you could possibly make, because there's a little inventory example that I have, which uses a small tool that's written in this language. So if you want to know where to find that, it's definitely here in the manual under the immediate mode UI. And then you can just scroll through all of the different subjects to learn how to write it. And you can use these in your game for a standalone game, for a Mac, Windows, Linux game. This is probably going to be performant enough. It's a little bit harder to manipulate than a retained UI, but I definitely would not recommend this in your game other than testing, especially if it goes to mobile. And I would take a look, keep track, and use our normal retained sprite-based UI. But definitely you need to know where this is. I'm not going to go into the details of how to write a lot of the IMGUI stuff. So when you get into writing your own material, you want to come here to the manual. You want to look at the immediate mode GUI and dig through it and figure out how to use it. So, pow, get rid of that. So, definitely, we want to see the GUI scripting guide for this, and like I said, this session is going to give us some hints on editor scripting, on GUI, and that sort of thing. And what is the main thing about scriptable objects? Scriptable objects contain data, and data can be boring, so there's not going to be a lot of sexy material today. It's just going to be a lot of sort of basic, straightforward, suck-it-up information. So what is a scriptable object? Primarily, scriptable objects are data containers. Scriptable objects are very similar to monobehaviors, which are the scripts that we attach to our game objects. The scriptable object is in parallel to monobehaviors. Both of them derive from the base Unity object. So they're Unity objects. They're squarely in the world of Unity, and they both are subject to Unity's serialization technique. We're going to talk a lot about serialization in this first half. Not necessarily something that you need to know to be able to use scriptable objects, but it's a good thing to get an idea of what's going on under the hood. Now, a scriptable object doesn't need to be, and as far as I know, cannot be attached to a game object. So they are pretty much either created at runtime and destroyed at runtime, which is not something that I'm very familiar with, though people have used it for that. But instances of the scriptable object can be saved as assets in our project. And that's primarily what we're going to be looking at in this episode. Now, I'm going to go ahead and look at chat and see if there's anything that's important. Tools like plugins, you mean? Pretty much. You can write editor scripts and editor tools to your heart's content, and you can literally rewrite the editor itself. So you can make new inspectors for components. You can make tools that do things. We've covered a number of them in tips and tricks and in live training sessions. But you can do things like create a tool that will place objects on the surface, and do a ray cast down during edit time. Find the surface normal, align the object to the surface normal. You can do node-based shader editing. People have written node-based shader editors directly in Unity. There have been several people who've written script editors that, you're replacing Visual Studio or MonoDevelop, and you can write your scripts directly in Unity, including code completion, color formatting, and all of that. So you can write pretty much what your heart's desire is in editor scripts, or you don't even need to do that yourself. You can go to the asset store and you can find that somebody else has taken advantage of this great ability and has made tools that you can download. Cool. Why use scriptable objects? Scriptable objects have two major uses: saving and storing data during an editor session, and saving data as an asset in our project for use at runtime on deployed builds. So, we're not talking about saving data, and I think this is one of the things I need to be clear about in this particular episode, which is that you can save data during runtime in the editor because it is using the editor namespace and editor scripting. But on a deployed build, you can't really use scriptable objects to save data. So they aren't, at that point, replaceable units for, say, saving a game. You can't use it for saving a game at runtime. So in the editor, we can save data to scriptable objects during edit and runtime. In our deployed build, we can use the saved data in our scriptable object. And for that, there's no need for third-party file formats. When reading data from a scriptable object, there's no need for XML or JSON or text. You don't need to be writing your own parser. You don't need to be parsing that text and turning it into an object. All of that is handled for you by Unity. So you can just access that scriptable object data directly, and you don't have to fuss around, which is part of the reason that I like it quite a bit. So you can also save large amounts of data with this. The documentation says that it can save millions of ints, for example. And then you can optimize the loading of data as you need it. One of the things about optimizing loading the data when we need it, so why use a scriptable object, is imagine a framework to keep track of, say, all the levels in your game. And so you had specific data about what, the enemy waves are and where things are placed. And if you had that as a standard class, you would have to load all of that information, the information about all of your levels, at the same time, and it would be taking up space in your memory. So with a scriptable object, you can start to make these into smaller packets. You can have one scriptable object, so you can have one level, you can save one level per scriptable object, and each one of those can be an asset, and you can have a reference to those assets, or you can have references or a list of references to the assets that you need. And then your framework only needs to load in the references, which are very small, and then you can access the data one level at a time, so that you don't have to keep all of that in memory, so that you can push all of that down as an asset. Now it's going to take up hard drive space, or drive space on whatever your device is, but you don't have to load it into memory. So you only would need to load into memory one bit of those at a time. So you can break all of your data down into multiple scriptable objects and then access that data as you need to, looking at one particular scriptable object at a time. Now, saving and storing data during an editor session. We need to understand a little bit about how Unity works at this point. So let's take a look and imagine about how Unity works. Unity internally has two parts. There's the C++ core, which is the main workhorse of the game engine. And then there is the managed, that should be a D, typo, the managed scripting side, which is the side where we write our components, where we write our game objects, where we have in our scenes. And the data must be passed between these two parts. So we take data from the managed scripted side and we save it in the C++ side. And to pass the data between these two parts, it must be serialized. It needs to be saved as data and then serialized and streamed and saved on the C++ side. And then, of course, it becomes deserialized and brought back again. Now, there is a very good blog post on this. There's an old one from 2012, and there's a new updated one, which was 2014, 2015, which includes some changes and some updates, including the fact that, yes, you can serialize structs internally inside Unity. And I will link that in the chat when we're done with the PowerPoint presentation, and also it'll be linked on the Learn page when this session is archived. Now, what is serialization? For those people who don't fully understand serialization, let's do a quick step back. It's the encoding of data for storage, either storage on file or storage in a file or storage on disk. There are two steps. There is serializing and deserializing, and there are a bazillion ways that we can do serialization. Unity has its own way of serializing objects and serializing data. Many of ways of serializing data are built into C# and in the .NET framework, and they can be used to save files to, say, text or JSON or XML. And for more information on serializing data, we have a live training session on data persistence on the Learn site. And this also will be linked to the project page when this is archived, and I will link it to you when we're done with the PowerPoint session. So when we enter and exit play mode, or we change a script and save it in Unity, we must reload the assemblies where the DLLs that are associated with Unity with a project are stored. But generally the idea is that you have these libraries with DLLs in them, and they need to be reloaded when we save a script or when we enter and exit play mode. So Unity will save all that serializable data by creating an internal representation of the data on the C++ side of Unity. And then it's going to destroy all the memory and information associated with the managed side of Unity. And then it's going to reload the assemblies, and then it will deserialize the data that was saved on the C++ side, put it back into the managed side. Now, what does this mean? This means things like, but not limited to, you cannot save changes during play mode. If you've ever noticed when you're running the game, when you're running your own game, you can make changes in the editor, you save your scene, you open it up into play mode, and then you can move things around, and you can change values, and when you're done, all of those things revert. Now, this is, to a degree, an advantage, and I always liked it. Some people don't, because it allows you to go into play mode, and you can play around to your heart's content. You can move barrels, you can change the number of enemies, you can move stuff around, and when you're done, it's non-destructive. All of those changes go away. Now, where some people find this frustrating is they forget they're in play mode, they make lots of changes to their scene, and then realize that they aren't persistent. Now, we're not going to go into it as tips and tricks. There are ways that you can get around losing all your data. But the reason that happens is because in play mode, we serialize all the data onto the C++ side. We go into play mode, and then when we're done, we then deserialize it all back, which will replace any of the changes that you've made while you're in play mode. The other situation that you can get into is editor tools could lose their data. So to survive an assembly reload, data structures and information must be serialized and saved into that C++ memory properly, and then deserialized and returned to the managed side unscathed. Now, serialization in Unity and the serializable attribute. There are two important attributes to know about, and they are system serializable and system serialize field. And if you're using system, you can just cut that down to serializable and serialize field. Now, classes and structs need to be marked as serializable if you want them to be serialized. So any of the classes that come with Unity and monobehavior, they're going to be serialized already. But if you create your own class or you create your own struct, they won't be serializable. One of the side effects means also that you cannot see them in your inspector while you're in edit time. So you add the serializable attribute, and then all public fields are serialized if they have a reference to that serializable class. Now, the non-public fields in those classes may not be or will not be serialized unless you specifically put serialized field on top of them. And then private fields are serialized under some or most circumstances. Essentially, in the editor, if you've marked your private field as serialized field, it will get serialized. And you can force some public fields to not be serialized just while we're in there with the attribute non-serialized. Now, serialization in Unity, two potential gotchas. Shared references. Unity serializes fields individually as a value, and this could serialize the same object multiple times. And this could decouple references when deserializing. Also, when shutting down the editor, some data may What did I write there? That also looks like rubbish. Some data may be saved. Yes, may be saved. That should have a D on it. Some data may be saved in the C++ side during the editor session, which means editor tools and that sort of thing. And on shutdown, this data could be destroyed as it's simply resident in memory. So these are two major potentials, which is that you're saving your fields as a value, and that in some editor tools, if you don't explicitly use them to save their information, will have their editor tools just simply being saved in resident memory. Using scriptable objects. We were doing a session on scriptable objects. It'd be nice to see that we're back here again as to why we're using scriptable objects. So using scriptable objects, shared references. References to scriptable objects are serialized correctly as references. So it's one of the things that is a reference. So when you serialize a reference to a scriptable object, it is serialized as a reference. So scriptable object references will be saved as a reference and won't duplicate data. This allows for that complex interactions to be stored correctly. Scriptable objects themselves will still serialize their references to other objects the same way as mono behaviors do. But as an asset, they're not being serialized and deserialized the same way as instances are in the project. So when we enter and exit play mode or the assemblies are reloaded, we don't have to worry that much about the same problems we do with things that are in our scene. And then lastly, data from editor tools saved to scriptable objects as an asset are written to disk and will survive shutting down the editor. I want to talk about serializing references. So scriptable objects, as we said, are serialized as a reference. Normal serializable classes are serialized as a value. But as an example, let's say we have two scripts that reference the same list of ints. So this is generally the example explanation for this particular slide. And at first, they will both reference the same object. So if you change the value of an int in one list, the other game object would see that same list and would update the same values. However, if you got into a point where those were serialized, the components are now serialized, they're saved on the C++ side, and that shared list is going to be lost because this can be saved as a value. So suddenly when they are deserialized and put back into the inspector, you're going to have two separate copies of that list, and they're going to be in the same state as when they were serialized, but then those two game objects can have that data starting to diverge because they're not shared anymore. So if you have that scriptable object, you're looking at it by reference. So you can keep the same reference on both of those objects. And what this also leads to is that your stored data will be smaller. Each game object is going to have a reference rather than a full copy of that data. And so only one copy of it is loaded in memory. So you only will load that scriptable object, and then the other objects that reference to it will only have that reference. It'll be faster to clone an object as they don't have that data to copy. So imagine that you have settings for your monster. So you've got your monster settings, and they all want the same data information. And so they all have a number of hit points. They all have, armor value, but a lot of data. They're going to have a pile of data that's going to help define what your monster is going to be looking for. If you include that as a class, every single one of these monsters is going to have that data associated with that particular game object. And so it's going to be duplicated. If, on the other hand, you have that as a reference to a scriptable object, then you have that data only once in the scriptable object, and all of those monsters merely have a reference. And this also will allow you to swap out that data file. So you could change the characteristic of that monster purely by changing the reference to which data file it's looking at to drag its data from. So types also, the scriptable object does not have to be the same type as the component as the component expects, so long as it's deriving from scriptable object, and it can be a subclass of the scriptable object that you've made, so that you can still associate things as a subclass without having it being the exact type that it's expecting. And you can also, as an aside, references can be null, which isn't really supported with serialized class or serialized struct, which is an advantage. I'm looking back at chat, sort of reading from the backup. Erin Die 1, basically the data has not changed at runtime in a scriptable object. That doesn't mean you can't start to write a parser, and, you know, as we've seen with normally saving data, you can save it as JSON, you can save it as XML. So you can save data to disk at runtime and bring it back. It's just that scriptable objects themselves are not the data structure that you want for saving data at runtime. So working with scriptable objects, Unity under the hood. When Unity is working with a scriptable object, the constructor is called on the scriptable object, the data is deserialized into the object from the C++ side of Unity, and then onEnable is called on that scriptable object. So for us as the user, we do not use, and that is in bold, we do not use the new keyword or the constructor. You could lose data. I think that's related to the fact that it's going to have data deserialized back on top of it. OnEnable is then called. So OnEnable is the best candidate for initialization. And we create our instances of scriptable objects using either the create asset menu attribute, which we'll cover in a moment, or use the scriptable objects static create instance method in a script. So the create asset menu attribute, this adds a new menu item directly to the editor's asset create menu. And then optionally, we can use named parameters to set the desired file name and the menu path and name and or the menu order. And since this is using named parameters, you don't need to use any of them, or you could use all three. So there's an optional file name, an optional menu name, and an optional order. And the example we have here is that you have something called inventory list data, and that's the name of the file that gets created. The asset, the scriptable object asset, there's a menu name, which is how it appears in the assets create menu, and we'll see that in a moment. And then you can organize the order in which they show up in the menu by using the order number. The order of the three parameters is irrelevant. You can write these in any order because these are named parameters, and then any or all of the parameters are optional. So scriptable object create instance. You can create scriptable objects by script. Normally we don't need to do that now that we have the asset, but there are times when you want to do that inside scripting. So the way you do that is you say my scriptable object class, whatever you've named the class, and then you give it a name, my scriptable object, equals static function, static method of scriptable object.create instance, and it will create the instance for you. This is not necessary as there is the attribute, but it's worth knowing about in the context of tool scripting, and we'll show, I've got an example of where I use that. So finally done with this wonderful PowerPoint presentation. Like I said, when we archive this, I'll make sure that these are all proper links. I'm going to leave this up here for a second, and then I'm also going to paste these into chat. These are scripting reference notes and also some other community sites that I've come across that I felt did a good job of describing scriptable objects, and so it's good for research. One of my favorites is Richard Fine at the London Unity Users Group, and I'll paste this into the chat channel in just a moment. So thank you for bearing with me as we blasted through that. Quick overview to things like serialization and scriptable objects. So let's go and take a look at something. It's not going to be, like I said, not going to be sexy tonight. And also, like I said, we don't really need to know all of the details that I showed you in the PowerPoint about how serialization works to use scriptable objects, but knowing how things work under the hood can always help. So I've got two examples here. And the first one is just a very, very basic example of how to use a scriptable object. And so I've got my scriptable object class, which I'm going to open here in MonoDevelop. There we go. So this is a very simple class. So you have a class name and it derived from scriptable object. And I've put some random public fields into it, a string, a bool, a color, and then a vector3, which I'm going to call spawn points, which I'm going to show you how to use in just a second. So we need a couple of things. So we've got a scriptable object that we create here, and then we use the scriptable object. So I've got a public reference to my scriptable object. And then I've got a private list, which is a list of lights. And I'll show you how I use this in a second. So in start, I make a new list, and then I do a quick loop. And so for each spawn in my scriptable object.spawnPoints, I create a game object. And then I add a component light, and then I set the transform position to the spawn from the data that we're getting from the scriptable object. I set that light to false, and then if we've selected that Boolean to be random, then I generate a random color for the light. Otherwise, I just use the light color that we have set in the scriptable object, and then I add it to the list. So we basically create a list, and we create some game objects based on the data that we give it. Now, there is an optional make my scriptable object. Now, this is the old way that we used to make scriptable objects. You needed an editor namespace, so you'd had to create a menu item, and then you had a static function, a static method, that would then call that scriptable object create instance with a type of my scriptable object class. And then you would need to take the asset database and create an asset. And then you'd need to save that asset that you've just created. And then in the editor utility, you'd want to focus on the project window and then focus on the selection that you just made. Now, essentially, we don't need to do any of this anymore. All of this is now done for us under the hood when we use the attribute, which I'm now going to hopefully bring up in another window. Yes. So we'll come back to my scriptable object class, and all we need to do is add that attribute. So that's our create asset menu. And before I save this, let's go back to Unity. And if we go to the assets, create menu, I do have a, assets create. I do have a create my scriptable object. And this is the script that we created. I'll show you. Make my scriptable object. So there's assets create my scriptable object. So now we've done a create asset menu. Let's go ahead and save this. And if we come back to Unity, we'll see that as soon as that compiles, in our assets create, we've got my scriptable object class. So that's done automatically for us. Now we can go ahead and fill up that attribute. So we can give it a file name. Let's just call it data, a menu name, inventory list, give it an order, any order that you want. And so when we save this and we come back to Unity, let it compile, we'll have our assets create, and there's inventory, and there's the list. And then when I select that, you can see we've created a data file, and then we can call this, inventory data, or whatever we want to call it. We can just call this, my scriptable object data. And if we look up here, we now see inside this asset all of the information that we've defined in our class. So normally we would expect to see this only when we created an instance of that class attached to a game object through some part of the hierarchy of a mono behavior. So we would have a mono behavior that referenced my serializable class, or we would have it as a mono behavior and directly attached, and we could see it on the game object. The advantage that we have now is that we now have a data asset. We could put it in another folder if we wanted to, and just call it our data. And then we can put my scriptable object data into our data file. So we can move them around. They're assets. We can move them around. We can duplicate them. We can rename them. So let's see it in action. Let's go ahead and create some spawn points. 5, and let's make a little line of them. I basically have a quad here that will allow us to shine some lights on it. So let's just sort of say, -4. Let's just make a line, and then -2, and then zeros, and then 2, and then 4. So now we've added some data, and let's just leave the color as white. We've got a use my scriptable object script, which will use it. And the use my scriptable object, remember, was that create a list based on the data and then put some lights on, and then if we hold the fire button down, we'll change the enabled state. So let's put that on something like the main camera. And then when we look at the main camera, we associate our scriptable object. So we hit save, and then we hit play, and we should get a bunch of lights. And then we hit the fire button, and we can see we can turn them on and off. Coming back to our data, we can say that color is random, and then when we hit play, we now have random colored lines. So it's essentially a data file. But it's in a familiar looking shape. They look like a script that we write that we've attached to a game object, except that game object sits as an asset. And we can duplicate these files. We can create new ones. So we can have as many of these as we'd like. Another data file. And we could do anything we want to do with this data. So the little thing I was going to do, which I was mostly me screwing around, and I'll put back into that script, doesn't really have anything to do with data. Just fun stuff you can do with it, which is that if we made an update lights, we could just change the color at random, and then just say in our update, if we hold down the Fire 2 button, it will call update lights. And so for every light in my lights, we pick a new random color when we hold down the Fire 2. Not sure why I wrote this, because it really doesn't explain anything to do with the scriptable objects, but it was fun. Tried to put a little bit of humor and sizzle back into this so we can do little disco lights. How about that? Disco lights. See, that was worth the price of entry, the disco lights, right? You'll put that in every one of your games. Anyway, so I'm noticing that someone is talking about little prefabs. I'm not going to back read to find out what he's talking about, but you can kind of use these as little data prefabs. I touched on this earlier, but as you see, I have 3 data files, and each one of these could hold something different weapon types, different enemy types, strong orc, weak orc, captain orc. They could be different items. We'll talk about that in the next example, where we're going to talk briefly about making an inventory system. And then, like I said, all you need to do is swap out the reference. This is just a simple reference. So we can see that this reference allows us to pick any of the related data files. So you can write that into your code in any way that you'd normally would, and be able to save all of these bits of data. So let's look at example 2. So example 2 is a sort of a mini inventory system. Now, this doesn't show the inventory backend. It's more of a way, again, as a detailed way of showing what you can do with a scriptable object to hold data at runtime. And then I will talk briefly about how you could extend this, which I didn't have time to write into this example. But if we look at the scripts, let me just go and look at these. And let's get rid of the previous example. So we have an inventory item, which I've made, a very silly, simple pseudo representation of an inventory item. It's got a name, it's got a texture, it's got a potential rigid body as an object, some characteristics, is it unique, is it indestructible, is it a quest item, that sort of stuff. What's its encumbrance value? And we've made this a serializable class. It's just simply a class. I will talk about how we could make this a scriptable object as a way of extending the system and the advantage that you'd have of it. So then we have our scriptable object, and our scriptable object is simply a list of these inventory items. And this is our data, this is our asset, and this sits in our game. In this particular case, we also have a create inventory item, and this does get used, unlike the previous example where we didn't need it because we had the attribute. This create inventory item, arguably, we don't need the menu item. If we wanted the menu item, we could use the attribute as well, instead of using just the typical menu item that we have here. But we call the inventory asset item list create in the editor script. Now, before I show the editor script, I want to show you what it does. So if we go to Window, we open our inventory item editor, we end up with an inventory item editor. And we can do things like create a new item list, and we can see it's created the new item list down here. I can show that list. So if I'm not selecting it, I can show that list. So I can find it. And again, it's an asset, so I can move it around. I could create, another new folder with my data in it, another data folder. Put that in. It'll be covered. If I wanted to, I could create a new list, but I have to get rid of it. New item list. There we go. I think that's overwriting it, I think, into the same place because I'm saving the, so let's change its name. X new item list. I think I'm saving that. I'll have to show you a look inside the list. But I can open an item list too by going to it. So let's just duplicate this. Duplicate. Open that list. Assets. Example 2. Data, get the list asset, and I can open that up. You can add items. And so this is all going into that scriptable item. Now let's look at, we can add a couple of these. Let's add 2 or 3 of these new items. They're all going to call new item. Look at the inventory list, and you can see it's just that normal list that you get. Collapse that. So there's our items. And so this is just a list, but all of this list is being saved in that scriptable object. All of the objects in your game that need to have a list of every potential type of item in the game doesn't need to have an instance of the item. It can look here for the data and grab the data here from this data repository. Now, this is where I was talking about a hint of on GUI and a hint of editor scripting. I don't want to go into this in great detail. We'll let you break this down for yourself, but we can take a look at the inventory item editor, and you can see that it's not trivial, and it's just the beginning. So editor scripting gets to be a lot of brute force, blunt GUI coding. Most of this is on GUI. And some of this is even functions that are called from inside on GUI. And so I would like to use this more as a jumping off place to let you realize that you can write tools in Unity in editor scripting, that you can have full control over how things are working. You can open asset paths. You can find new assets. When you're in here, you can do things like, let's just pretend that these are pictures, that I've got blue thing, big blue thing, something that you can get from a drop off of a, I don't know, big red thing. You can scroll through. So I've got a red thing. The item, what am I doing? Red thing. So, and you can see that the list is updating over here. How could we extend this? Well, let's talk about another layer of scriptable objects. Where I think this particular system is weak, and I think it makes a very good example, but where it is potentially weak is in the fact that this is run as a list of a class. I think that this could be improved upon by deriving this as well from scriptable object. And then you could create new scriptable objects for every one of these, and this would be a list of scriptable objects, and you would have an asset for every item in your game. And the advantage that you would have of doing something like this is you would have independent version control handling for each individual inventory item. You wouldn't get into a point where you're trying to version control a list, because in the instance list, you make all of your changes here. You have one real object. And if you suddenly wanted to go back and get to a point where you wanted to change one thing and not another, you're going to be doing it pretty much by hand. Say in a large adventure game, there'd be lots of inventory items in the game, and you wouldn't want your designers having constant merge conflicts from having to edit the same file. Ease of editing individual items. where you can have each item can build up a fair amount of data, localized text. You can have speech assets when you look at them in the inventory description. You could have different graphics. You could have different models, and so all of this could be saved as an individual asset, as a scriptable object. Ease of referring to individual items. One of the other problems with this particular system is you pretty much end up referring to things by a string or a hash, or maybe a unique ID of some sort, based on the data that you put into that instance of that class. So if you wanted to set up a door that could only be opened by a particular item in a player's inventory, you could have the script just have a public inventory item variable that you drag and drop the item onto as the project, and that's what it's looking for. So it's pretty clever. It saves you from having that string or hash lookup. It also means that if you rename them later, you don't have to fix all of the references in your game. Whoops, we had the big red thang. Oh dear. We don't want a typo, pwned. And we don't want a typo, and so suddenly we have to go through and correct everything that's looking for string lookup. Whereas if it's looking for the item itself, you don't have to. You end up with a big pile of assets. Is there a good way to manage it? When you're dealing with a class, you can zip it into a dictionary, which is one of the advantages of this current system. But you could, say, arrange all the stuff you wanted in your project and start doing a search. Look for asset database.find asset by type to get the GUI IDs, and then you could use get asset path from GUI ID to return the GUI ID, and then you could do a load main asset to load the inventory item. But alternatively, you could just manage this manually. I think that by the time you got it down to assets, you could be managing those assets directly. You could put them into a different library for each act. You could sort them in any way that you really wanted to. So generally, I feel that you could improve this system by turning the items themselves into individual scriptable objects. Anyway, so that's it. Let's see, how am I doing? Let's look at the time. Woo! Perfect. So, questions about scriptable objects. I'll see if I can answer them first, and then we can move on to some general Unity Q&A. I'll stick around for, I don't know, half an hour or so, see how the chat is going, and then from there, we'll see what we can do. So, Leon Moran 86 asks, can you reference a scriptable object from another one? I would assume so, yes. It makes sense. I can't see any reason why you shouldn't be able to. And I'm assuming so with my concept of having a scriptable object list with a scriptable object in it. So yes, if not, then I will eat my hat. Palm Grove Soft asks, if the scriptable object equals an item, how can one use it at runtime, attach the prefab instance from code? In general, what you want to do is have the data listed in the scriptable object that defines the item. And in many cases, items in many games are completely abstract. You'll have a picture of a potion in your inventory, but you never actually see it. It's just data. And when it's activated, it does something to you, but you often never even see it in your hand. So you build your game around the information that that item can have, which is that you could have a model that would become a game object reference. In this case, we have a game object as a rigid body, but that, can be an entire game object. But the reason why I used rigid body is it requires that there's a rigid body component attached to the game object. So you'd have a model and a rigid body and a collider, and you could, say, throw it into the environment, it'd fall to the ground, and you could pick it up. And the way that I solved it in one of the prototype games I worked on was that I had a lootable item class. So if you clicked on it, it would transfer into your list, into your inventory list, and an instance that you had this item, and then destroy the model in the scene. And so when you spawn it, part of throwing something away and putting it on the ground will throw a model down that has a lootable script on it. Monry Mobile says, do I call set dirty for a scriptable object in the editor window? In certain cases, yes. I have that down here. If GUI changed set dirty inventory item list. And that will set the inventory item list as dirty, and so it'll go ahead and get updated. Mandy Saw asks, can you use file open dialog with create asset menu attribute? They seem to be two different things. The way I'm seeing it is that I have a file open. See, on enable, I have this as on enable. I'm finding the object path. I'm finding the load at path. I'm loading the inventory item list from the asset database using the path that I've saved in editor prefs. And if there is no path saved in editor prefs, then you don't have any data file associated with it. Hopefully this won't break. I think I've trapped it properly. So if we have none, this should just say, yeah, we don't have anything here. We can open an existing one. Sorry, I don't have one. But I could create one going asset, create inventory item list. So that creates it. And then I can use the open an existing one and then just go ahead and open it using the open dialog box. That should work. Did I break it? Oh, what have I done? Ah! I've broken it. Now that's probably... Did I generate a new one? Let's look at the create new. Should create, because that's the instance of the list. Yeah, new inventory item list. Open. Oh, it's because I'm not opening it. Because I've created a new thing and I haven't necessarily created that new list. And if we haven't opened it in the inspector, then the inspector will create new lists automatically. But if I've just created it, haven't looked at it in the inspector, inventory item list. So I would need if inventory list dot item list is null. Inventory item list dot item list equals new inventory item list. Whoops. You're going to compile. There we go. Yeah, what I had done is that when you create new objects, inventory item list, until you look at it in the inspector, it doesn't create a new list. So the script, I have to make sure that if it's empty, it makes one for me wherever I added that open list. I have to make sure that I create a new one. Otherwise, it's going to be a null ref and it'll lock things up. Which just makes sense because the inspector just nicely makes a new one for us just by looking at it. But if not, we have to do it ourselves. Now we can open that item list. Open existing one. Assets. There we go. Yay. GM Liquid Media asks, can scriptable objects work with asset bundle management, adding, say, a new gun that has the same attributes that the current scriptable object already has? I mean, I would assume as an asset that there is no problem with asset bundles working with scriptable objects. I can't imagine there being an issue. Leon Moran 86 asks, can a group of SOs, scriptable objects, be added to a dictionary? But I can't see why you couldn't make a dictionary because it's just a key value pair with a reference to the dictionary and probably a good way to go. Owoshib asks, just trying to get my head around it, so you could use this as a type of different weapons for use in a game object database and have it stored remotely so that you could add a new item, sort of like an sort of easy deployment. You should be able to. I mean, if you have your references correct, you should be able to, you know, make that part of a new downloadable content in an asset bundle. It should work. I can't see why it wouldn't, because it is data. It just needs to make sure that the asset bundle is saved correctly. And there are some issues, again, like with set dirty and making sure that the asset is appropriately saved to disk. It should work. Hydroson asks, how important to development are scriptable objects? Is it kind of niche thing? Is it a kind of niche thing, or is it essential? Well, nothing is essential, depending on how you do it. I find that it is very useful, however, to have saved data as an asset that objects in your scene can refer to. Drakani asks, we can't save values at runtime, but can we modify them after grabbing them from the scriptable object? For example, an item has a default price, but some places it costs more or less. Can we modify the value at runtime? Yeah, I mean, it's just data. So it'd be the same thing that you would have where if you had a base cost, and then you could say, the base cost is 100 gold coins, but due to his charisma, he gets a 10% discount, so it's worth 90 gold coins, yet he's friends with the king, so it's 75, but he's a criminal, so it's worth 150. I mean, you could do all sorts of stuff with that data once you have it. Sklatter asks, can scriptable objects save references to behavior scripts? I would suggest that, like most assets, they can only reference other assets, which could include prefabs to a degree, but they aren't going to be able to reference anything as an instance in a scene. Leon Moran, 86, asks, what are the performance implications of using loads of scriptable objects? I don't think it's anything better or worse than using loads of any other amounts of data. I'm not aware of any particular performance problems. They are simply data repositories that you associate by reference, or arguably by path or by resource load. So other than the fact that in any case, the more data that you have and the more things you are accessing, the slower things are going to go, I can't think that there's a particular performance issue or any way to do it necessarily to make that. I can't see it being any better or worse than any other way of saving data. Kav Meneka says, is the most easy way of loading content that it was made in Unity? Well, there's a convenience that something like scriptable objects is built in, and it doesn't require that you write a parser. If you have your own data structures, and we now have improved Json compatibility, and I've seen some very good XML tools out there that you can save objects very easily in JSON or XML, though I've done more JSON than XML recently. And so saving and recovering data is relatively easy, but because it requires an additional step and an additional set of experience to be able to look at parsing some information, many new users find it a little bit difficult. And the scriptable object bypasses all of that by just sort of cutting straight to the chase. And there's a data repository. It looks like the same stuff that we have. You write a class, you put an instance, you put it on a mono behavior. We know what it looks like. You make a scriptable object. It looks exactly the same. So it's easier for many people to get their head around once they know they're there. But I don't want to discourage people from saving or importing data from more traditional styles if that's what suits them. Pseudocat429 says, is there native JSON support in Unity now? Then what is it? I have to look up the feature. I have not paid a ton of attention to it. Unity JSON support serialization. Well, there's the documents page. And what does it say? Looks relatively straightforward. So yeah, I know that we've had this as a feature and it came out in 5.3, but specifically I have not used it yet. Mandy Saw asks, if you save a scriptable object as a sub-asset, like your version 1 inventory, how do you update, delete them individually? You don't really change this. I mean, the idea is that this inventory this isn't what the player is holding. This is the Platonic list of all of the items in your game. So every item that you have in your game is listed in, you add every item for every, not just what you have in your game, but you have to define, blue backpack, you know, and it has all of its definitions, and then, oops, you know, sword of death. Winslow puppet. And that is definitely indestructible, if you know anything about Winslow. And then you would have an inventory list of what the person is carrying, and then the idea of what's in each slot. And that can be very simple, where you have an inventory item list, and you just can add different versions of this instance into it. So you go, he's got a blue backpack, and in it is a sword of death and a Winslow puppet and pants of the eagle. Oops, learn how to spell. So this is the file that you define what all of your items are, and then you can use the items in your game in another format. So Sudocat429 is asking, if you were making a database of items for an RPG game or some such, what performance benefits would scriptable objects hold over an external database like MySQL? I mean, again, this is the definition, not necessarily how you would be running your multiplayer game. You're still going to need a database. Generally, this was just an example of how you would define a list of items. I'm not sure you want to run scriptable objects as a database, because you're not going to be changing that data as you go. The scriptable object here holds the data that defines a thing. So you would have, like I said, a scriptable object for this particular type of gun, and it holds all the data about that gun. Or maybe it's a component of a gun, and then your framework says, if I've got this type of trigger mechanism and this type of silencer and that type of stock, I therefore sum up to a particular type of weapon. But this is where you would store your original data that you base all of your items on in the game. So this is the data structure where you define what the items are and what they do, and then you have other bits of data that store what the characters have, and that's going to be something that has to be plastic, that has to be mutable. If you've got a multiplayer game, yeah, you're going to want a huge database somewhere that's constantly flicking over and adding potions and subtracting health and doing all the things that the game has to do. But somewhere you need to define what these items are in some sort of data structure, and scriptable objects not a bad place to have it. And then again, part of the reason for this is that you don't want to have a class, because let's say you had, you know, a class that defined your weapon and a class that defined your enemy, and then every enemy would have that class, and every enemy would be holding that data. So every enemy would be a large duplicate, and every enemy would be encumbered by the definition of their gun and the definition of how they behave. Whereas the advantage of pushing this off onto a data structure like the scriptable object is you have the definition sitting as assets, and then you end up with 100 soldiers that all look to one asset to define their current behavior. They all look, there's 100 guns that look at the data to figure out what their behavior is, so that each one isn't carrying the definition of what they are with them at all times. R&D1, how can I save my items if I make a game like WoW and the items are scriptable objects? Well, this is actually the basis of it, is that there's a definition for every item, and then what you need is the next layer is a list on the player. That's a list of inventory items, and when you're running that list, you run the list to keep track of. I'm going to make some back pocket code here. It's not really going to be real, but character inventory. I mean, this is probably not the way you do it. It's going to be, it would probably be incorporated in something slightly different. And then you'd probably have, why are you showing up red? I don't like that. There we go. Private, I mean, collections generic. Inventory item. And then this is something that you'd need to have, a private void, just void, add item, inventory item, you know, and then avoid index. It probably depends how you track it, you know, so you'd have an index in your inventory that, ooh, that's not what I want. And this item list would be really what your character is carrying. And you'd have a definition for how many slots, you know, then you'd have to have, you know, so the inventory length would be related to how many slots you had. So you'd need to set up your original inventory. You know, so that this is something different from the definition of the items. The inventory items that are available are going to be defined in instances of your inventory item class or your scriptable object. And so each instance that you have is going to have the definition of the item. And then on your character, you're going to have a list of the items that are made available, and you'll tie it back to your original inventory item list, your sort of platonic. So these are your pure items that you have. It'll list every possible item in the game, but it's only going to define each one once. But then your character inventory, well, let's make this public so we can look at it. See if I can come up with a good definition, because it takes a while to build one of these. You know, and so you'd have your items in here. I'm trying to think of a good way I can show this short quickly, because I've made a couple of these. And the inventory item is relatively easy to define and to move around. Or you can, sometimes you just need to do it by name or by ID. And you can have multiple instances of the same one that's in the character inventory. You just want to be careful, because if you've saved your data as scriptable objects, you don't want to start copying tons of it back over again. You just want to reference to the item, or the item data itself, and try to keep that in your project level. I'm not sure there's really time for me to show more than that, but we definitely have plans to show some simple inventories and how to manipulate this that's on the books, and we should start seeing those in the next couple of months. Hopefully this helps you get an idea that you've got this other layer where you've got your definition of all of your items in your scriptable object, and then your character has lists of how many of these items that they're carrying, but they refer back to the scriptable object. Well, I'm going to start wrapping it up, I think, and don't forget you can get a hold of me on Twitter. You can get a hold of us, actually, on Twitter. So that's at Unity 3D, at the Ant Ranch, which is me, Will Goldstone, at Mike Geig, and at Matt Mirafish. All right, I'm going to wrap it up. Anyway, I'm going to go offline, and I will talk to you later.